All right, we want to come up with a function that would fit for this piecewise function. Now you'll notice that there's 4 different parts, 4 different line segments put together. So we're going to have 4 different equations. And so we'll have one equation for the first 2 hours, another equation for 2 to 4, and then another equation from 4 to 5, and another one from 5 to 7. For this first piece, you can do rise or run to figure out the slope. So you rise 20, run 2. So our slope for that piece is 10. And then the y-intercept is 0 because it crosses the y-axis at 0. So we can write y equals 10x plus 0, or y equals 10x. Then if we rewrite it with d of t in place of y, and then t in place of x, we'll have d of t equals 10t. So that's the equation for that piece of the graph. For that second part, find the slope. Do rise or run. So rise from 20 up to 80, so that's 60. You can subtract if you don't realize how much you're at going up. And then we go over 2, so our run is 2. Divide that, you get 30. So our slope is 30 for this piece of the graph. Now let's use the point 220 as our x sub 1, y sub 1, and we can substitute into point slope. So on that particular one, you couldn't look at it and find the y-intercept, so we'll use point slope. So our x sub 1 is 2, y sub 1 is 20. Substitute in, notice the minuses are in the formula. So we have y minus 20 equals 30 times, in parentheses, x minus 2. Now we need the y to be by itself, so to get rid of the minus 20, we'll add 20. And so we'll just put that plus 20 out to the side. And then if we rewrite that in terms of d of t instead of y and t instead of x, we'll have a match for choice A. From 4 to 5, our slope is 0. We rise 0, run 1, so our slope 0. And the y-intercept, if we extend that out, we can see where it will hit at 80. Anytime it's that constant part of the graph where the function is constant, we can just write, in this case, d of t equals whatever that value is. That distance is 80 the whole time on that horizontal piece. And then for the last part of the graph, we're going from 80 to 120, so that's a rise of 40, run of 2, so 40 over 2 gives us 20 for our slope. And then we can do point slope again. The leftmost point is 580. That's going to be my x sub 1, y sub 1, and again my slope is 20. So substitute in to point slope. We need the y to be by itself, so we'll add 80 to each side. And then we'll rewrite that with d's and t's. So d of t equals 20 times, in parentheses, t minus 5, close parentheses, plus 80. Similar situation here. Do rise over run to find the slope of the first point, part of the graph. Rise 100, run 2, so our slope is 50 for that part, and our y-intercept is 0. So you can write that as y equals, y equals 50x plus 0, or y equals 50x, and then if we rewrite that in terms of d's and t's, we'll have d of t equals 50t. For the second piece of the graph, that's that constant piece, that's 100. So d of t equals 100 for that portion. For the third part, let's find the slope. So we rise from 100 to 120, so that's a rise of 20. We'll run 1. So our slope is 20. If we use the point on the left-hand portion of the graph, we see 4, 100. Now you can use any point, but I'm going to stick with that left point. Substitute into point slope, y minus y sub 1, y minus 100 equals 20m times x minus x sub 1, which is 4. We need the y to be by itself, so we'll add 100 to each side. And we'll have y equal to 20 times x minus 4, close parenthesis, plus 100. If we change that to d of t's, we'll have d of t equals 20 times, in parentheses, t minus 4, close parenthesis, plus 100. So that would be a match for part D. And then this last piece will rise 20 run 2. 20 over 2 is 10. So our slope's 10. The point, leftmost point would be 5, 120. Substitute in y minus from the formula. Y sub 1 is 120. M is 10. And then x minus 5. We need the y to be by itself, so we'll add 120 to each side. And so we'll have y equal to 10 times x minus 5, close parenthesis, plus 120. So you'll see that that's a match for choice C. All right, you'll notice on this one, only some of the time intervals are in place. So we'll put 1 to 3 for the second piece, 3 to 6 for the third piece. All right, for the first part of the graph, you're rising from 0 to 80. So that's a rise of 80. We run to the right 1, so our slope is 80. The y-intercept is 0, and so we'll have y equals 80, or sorry, 0. Let's see, 80 times x plus 0. So you can write that as y equals 80x, and then if you change it to d of t equals, we'll have 80t. For the second part of the graph, we rise from 80 up to 100. So our rise is 20. We go to the right 1, 2, so our run is 2. So the slope for that part of the graph is 10. Now we need to find a point on that part of the graph. The point on the left is 180. So that's going to be my x sub 1, y sub 1. Point slope y minus 80 equals m, which is 10, times x minus x sub 1, which is 1. Then we need the y to be by itself, so we'll add 80 to each side. And we'll have y by itself equals 10 times x minus 1 plus 80. Now if we change the d of t's, we'll have d of t equals 10 times x minus 1 plus 80. For the next part of the graph, it's that constant piece, that horizontal piece. And so we can just write that that is 100. Notice that. Slope would be 0. Y-intercept, if you extend this out, so if you extend this horizontal piece out, you'll see that it intersects it at 100. So slope is 0, y-intercept of 100. You can simplify that to just 100 for the equation. All right, now for this last piece, we rise 20, we run 1. So our slope is 20. The point for that leftmost piece, or leftmost point on that part of the graph will be 6, 100. So that's going to be my x sub 1, y sub 1. Substitute into point slope, we'll have y minus 100 equals 20 times x minus 6. We'll add 100 to each side. And so we'll have y equals 20 times x minus 6 plus 100. First of all, you can fill in your time intervals. We're going from 0 to 1, from 1 to 3, from 3 to 6, and from 6 to 7. For the first piece of the graph, your rise is 40, your run is 1, so your slope is 40, and so we can write y equals 40x plus 0, because it crosses the y-axis at 0. If we change it to d of t's, we'll have d of t equals 40t. Again, because we're able to see that y-intercept, we can use slope-intercept. For the next part, our rise is 20, our run is 2. So 20 over 2 simplifies to 10. So our slope is 10. If we use the leftmost point, that'll be 140. So that's going to be my x sub 1, y sub 1. Substitute into point slope, we'll have y minus 40 equals 10 times x minus 1. You can add 40 to each side. That'll get the y by itself. Write it in terms of d of t's. D of t equals 10 times t minus 1 plus 40. Next portion of the graph, the rise is 0, run is 3, so our slope is 0. The y-intercept, if you extend this out, you'll see it hit at 60. And so you can write y equals 0x plus 60. Or if you've been tracking with us, you can just write 60. So y equals 60, or d of t equals 60. And then for this last portion of the graph, we rise 10, 20, we run 1. So our slope is 20 over 1, or 20. So slope of 20, locate that leftmost point, and we'll have 660. So that'll be the x sub 1, y sub 1. Substitute into the formula y minus 60 equals 20 times x minus 6. Add 60 to each side. That'll get the y by itself, excuse me. So y equals 20 times x minus 6, close parenthesis, plus 60. Change it to d of t's. D of t equals 20 times t minus 6, close parenthesis, plus 60. So that's how you can build linear piecewise functions.